Mabuhay Philippines! Welcome to DepEd TV. My name is Sir Pao, your tech teacher in technology and livelihood education. Today, join me as we develop your life skills in information and communications technology, or ICT. To those watching us live via DepEd TV official Facebook, do not forget to post a picture of yourself while watching us and use the hashtag #ILoveTLE. Make sure that your post is public. And also please observe proper netiquette. Netiquette means network or internet etiquette. Do not forget to be polite and respectful at all times. Avoid posting foul or harsh words, so think before you click. Be ready, get your pen, paper, and self-learning module, and let's begin our ICT journey. Welcome back, learners. For our 8th and final episode for this quarter, let us have a quick recap of what we have learned from the first part of testing electronic components. With pride and honor, let me call once again our teacher from the future, Teacher LE, to give us the review.
It's a pleasure to see you once again, Sir Pao, and all the Filipino learners out there as well. In part 1 of testing electronic components, we learned the schematic diagram. A schematic diagram shows the components and interconnection of the circuit using standardized symbolic representations. In the electrical and electronics industry, a schematic diagram is often used to describe the design of a piece of equipment. Schematic diagrams are often used for the maintenance and repair of electronic and electromechanical systems. In line with this, we also learned about the common electronic components and their schematic symbols such as the resistor. Resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines. The capacitor. A capacitor is a device that stores electrical energy in an electric field. A capacitor can store electric energy when it is connected to its charging circuit. However, that stored energy can dissipate when it is disconnected from its charging circuit. So it can only be used like a temporary battery. Capacitors are commonly used in electronic devices to maintain the power supply while the batteries are being changed. The inductor. The inductor, also called a coil, choke, or reactor, is a passive two-terminal electrical component that temporarily stores energy in a magnetic field when electric current flows through it. The DC, or direct current source. An electrochemical cell or battery is a prime example of DC power. Direct current may flow through a conductor such as a wire, but can also flow through semiconductors, insulators, or even through a vacuum, as in electron or ion beam. The wire. A wire is a single, usually cylindrical, flexible strand or rod of metal. Wires are used to bear mechanical loads or electricity and telecommunication signals. The switch. A switch is an electrical component that can disconnect or connect the conducting path in an electrical circuit, interrupting the electric current or diverting it from one conductor to another. And the load. An electrical load is an electrical component or portion of a circuit that consumes electric power. This is the opposite of a power source, such as a battery or generator, which produces power. Examples of load in electric power circuits are appliances and lights. Combining all of these components can make a simple circuit. In the last episode, we also asked you to prepare a multi-tester tool and some materials such as a resistor, a capacitor, a diode, and a transistor. Today, your lesson will be focusing on using the multi-tester tool. We will discuss its parts and basic usage in measuring resistance, testing a capacitor, a diode, and a transistor. Teacher Pao, back to you.
Thank you, Teacher Ellie. One of the basic procedures in troubleshooting a device is the component testing. The cause of the malfunctions of a device is due to a defective component or part in the circuit. To isolate the problem, knowledge in basic troubleshooting techniques is needed. A multi-tester, either analog or digital, is the basic testing and measuring instrument used in troubleshooting electronics devices. So now, get your multi-tester, notebook, and pen ready and listen carefully. According to our previous lessons, what are the two types of multi-testers? Well done! The two types are the analog multi-tester and the digital multi-tester. What is the difference between the two? The analog multi-tester or multimeter uses a moving pointer to display readings, while the digital multimeter have a numeric display and may also show a graphical bar representing the measured value. An analog multi-tester has several parts. They are the meter scale, nameplate, needle corrector, positive test probe, negative test probe, alternating current or AC voltage selection range, direct current or DC voltage selection range, resistance adjustment knob, needle pointer, ohmmeter range, and DC milliammeter range. Now that we are familiar with the different parts of the multi-tester, let us learn the basics of how to test the following electrical components if they are still good: a resistor, a capacitor, a transformer, a diode, and a transistor. Resistors. Resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines. How to read a resistor's value the easiest way? First, you need to have a resistor color guide. Second, determine the colors of the resistor. In my example, my resistor's colors are brown, black, brown, and gold. Following the color codes, the first significant figure is brown and has a value of 1. The second significant figure is black and has a value of 0. And the third color is brown, which is the multiplier and has a value of 1. And the color gold has a value of 5%. The color gold stands for the tolerance band. It means that there is a plus or minus 5% in the total value of the resistor's reading. The easier way to read that value is just to keep the first two values the same. We know that our multiplier is 1. Let us convert that 1 into 1, 0. If our multiplier is 2, just convert that into 2 zeros. Therefore, our resistor's value is 100 ohms. Resistance is measured with an ohmmeter and is represented by an omega symbol. When using an analog multi-tester to measure resistance, it is necessary to calibrate the multi-tester first. In calibrating the multi-tester for measuring resistance, do the following. Step 1. Adjust the range selector to the lowest ohmmeter value, which is ×1 or x1. Step 2. Connect the test probe pins together. Step 3. Use the ohmmeter adjustment knob to adjust the needle pointer and set it to 0. Step 4. You may now begin testing a resistor. Since we know the value of the resistor, Let's check if our manual reading is correct. Attach the test probes at both ends of the resistor. There is no polarity involved, so you may connect the probes wherever you need to connect them. Observe that the ohmmeter reading is at 100 ohms reading with a 5% plus minus value. Therefore, your manual calculation is correct. Congratulations! You just have learned how to check a working resistor. Now, let us learn about capacitors. A capacitor can store electric energy when it is connected to its charging circuit. However, that stored energy can dissipate when it is disconnected from its charging circuit. So, it can only be used like a temporary battery. Capacitors are commonly used in electronic devices to maintain the power supply while the batteries are being changed. Capacitance. It is the ability of the capacitor to store an electric charge, and the unit of capacitance is called the farad. Now that you have a good understanding as to how a capacitor should function, let us investigate how to diagnose capacitor malfunction. A faulty capacitor may have one of the three basic problems. A shorty capacitor, which is easy to detect and is caused by contact from plate to plate. An open capacitor, which is again quite easy to detect and is normally caused by one of the leads becoming disconnected from its respective plate. A leaky dielectric or capacitor breakdown, which is quite difficult to detect as it may only short at a certain voltage. This problem is usually caused by the deterioration of the dielectric. The capacitor with this type of problem is referred to as a leaky capacitor. Here are the steps in the proper way of checking a capacitor of 600 microfarad using an analog ohmmeter. Step 1. Ensure that the capacitor is discharged by shorting the leads together. Step 2. Set the ohmmeter switch to times 100 or x100 range. Step 3. Connect the test probe to the capacitor, the black test probe to the negative indicator, and the red test probe to the positive terminal. The needle pointer will deflect rapidly to 0 ohms initially. Amazing! You have just learned how to check a working capacitor. Step 4. While the test probe is steadily connected to the capacitor leads, the needle pointer should then return to infinity as the capacitor charges. A transformer is a device with primary and secondary windings. It will transfer power from the primary windings to the secondary windings through induction. An open transformer in the primary winding will prevent any primary current, and therefore, there will be no induced voltage in the secondary current, and no voltage will be present across the load. An open secondary winding will prevent the flow of secondary current, and once again, no voltage will be present across the load. A partial or complete short circuit in the primary or secondary winding of the transformer will result in an excessive source current that will probably result in the overheating of the transformer, which could lead to being burnt. There are several ways to test a transformer, but for this episode, we will just talk about the safest way in doing this activity, the checking for continuity process. Check for continuity. Step 1. The range selector to see or find this symbol. This symbol means continuity. Step 2. Connect any test probe to the extended wire of the transformer. Step 3. Connect the other end of the test probe to each of the pins. If the needle pointer deflects, there is continuity. If not, the connection is cut. There you have it! You have just learned how to check a transformer by checking its continuity. A transistor is a semiconductor component basically used as a switching or amplifying signal, and it has two types, the NPN, and the PNP, and with the three leads called the base, the collector, and the emitter. Although transistors are an exceptionally reliable component, they will still malfunction. These failures are normally the result of excessive temperature or current or mechanical abuse and generally result in one of these three problems. 1. An open circuit between 2 or 3 of the transistor's leads. 2. A short circuit between 2 or 3 of the transistor's leads. And 3. A change in the transistor's characteristics. Let's test this transistor if this is a working transistor. Step 1. Set the analog multitester range to ×1 or x1. Step 2. Connect the negative test probe to the base and the positive test probe to the emitter. The needle pointer should deflect. Step 3. Connect the negative test probe to the base and the positive test probe to the collector. The needle pointer should deflect. The reading must be the same as the reading in step 1. Perfect! You have learned how to test a transistor. Diodes are semiconductor devices which are used to convert alternating current to direct current. The two electrodes or terminals of the diode are called anode and cathode. The symbol of the diode is shown here. The arrowhead points in the direction of the conventional current flow in the forward biased condition. That means the anode is connected to the positive side and the cathode is connected to the negative side. An ohmmeter can be used to check whether a diode has a malfunction or is operating correctly. A good diode should display a very low resistance when it is biased on. An ohmmeter can be used to check whether a diode has malfunctioned or is operating correctly. A good diode should display a very low resistance when it is biased on, forward biased, and a very high resistance when it is biased off, reversed biased. A good diode must conform to these two conditions. Otherwise, it is considered defective and will need to be replaced. The three possible defects that can occur in diodes are: open, shows very high resistance on forward testing; shorted, shows low resistance on reverse testing; and leaky, shows small amount of resistance when reverse tested. Step 1. Set the analog multitester range to ×1 or x1. Step 2. Connect the negative test probe to the cathode side and the positive test probe to the anode side. The needle pointer should deflect. Otherwise, if your connection is wrong, there will be no multitester reading. If you are using a light-emitting diode, it should light up when the probes are connected properly. There you have it, learners! Congratulations on learning how to test an electric component using an analog multitester. To give us a quick recap, I am turning you over to our teacher from the future, Teacher LE.
Thank you, Sir Pao. For today's lesson, you learned about the different parts of an analog multitester. Aside from that, you also learned how to test the following electronic components: the resistor, the capacitor, the transistor, the transformer, and the diode. Always remember, learning never stops here in Technology and Livelihood Education.
What a wonderful way to end our ICT session. Join us once again for more fun and exciting episodes of Technology and Livelihood Education for the second grading period. Let me leave this quote by Alvin Toffler with you. The illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. You can still watch the replay of this episode on YouTube and Facebook. Just search for DepEd TV Official and have fun learning. Once again, I am your tech teacher, Sir Pao, saying, quality education will be achieved when one is eager to learn and is innovative. In TLE, there is life. Together we learn as one, and this is DepEd TV. Hashtag I love TLE.